What if Berlin's monuments could whisper their construction secrets? This city is a patchwork of ruined stones, modern glass, and bold concrete, each landmark carrying an engineering story you won't spot on a postcard. From triumphant gates to a broadcasting needle and a painted wall that remembers a divided city, Berlin feels both ancient and futuristic. Let's peel back the facades and listen to the blueprints that actually built Berlin. Across the boulevard, we step from public memory into a classical engineering problem solved with stone and proportion. The Brandenburg Gate looks like a simple triumphal arch, but its 12 Doric columns are a textbook solution to carrying enormous loads with elegance. Standing about 26 meters tall including the quadriga, the gate is built from Elba sandstone, roughly 12,000 cubic meters of it, arranged in interlocking blocks so the whole thing behaves like a single heavy puzzle. Those 1.75-meter wide column bases aren't decoration. They channel enormous compression straight down into a 3-meter deep raft foundation, so the quadriga's 12.5-ton copper mass above doesn't wink under wind or weather. Imagine each column as a giant tree trunk transferring weight into the ground. The entablature across the top takes only limited tension while the columns do the heavy lifting. Over 2 centuries, the gate survived wars, reconstructions, and restorations because its post and lintel logic is brutally simple and shockingly durable. Today, locals stroll through its narrow central passage and feel the axis of the city, a human scale inside monumental proportion. From classical stone to a modern political stage, enter a building where light, glass, and mirrors rewrite the rules of public access. The Reichstag's renovation turned a heavyweight stone palace into a living machine of light and transparency. Norman Foster's glass dome, roughly 40 meters across and nearly 24 meters high, sits atop a reinforced limestone body and a modern concrete core. A 230-meter helicoidal ramp wraps the dome so visitors can ascend while daylight pours down a central mirror cone, reflecting light into the plenary chamber below. That mirror isn't just pretty. It directs daylight while helping natural ventilation, creating an energy choreography between glass, steel, and the old masonry. The dome's laminated safety glass and 3,000 square meters of panels sit on a steel frame of roughly 800 tons, designed to resist wind loads and channel gravity through new steel columns into the underpinned concrete raft. The effect is political as much as structural, a metaphor you can walk through, where transparency is literally built above the people's chamber. Now the skyline rises again, a copper crown that solved a difficult geometry problem with a double shell and clever support. The Berliner Dom looks like a colossal crown of copper and stone, and its engineering is just as theatrical. At about 116 meters tall with a 33-meter dome, the cathedral uses a double shell dome and internal steel trusses to control the huge lateral thrusts that domes naturally produce. Think of the outer copper shell as a raincoat and the inner shell as the structural sweater. Together they share loads, keep out weather, and allow galleries inside. Underneath, massive piers and arches funnel gravity into a reinforced concrete raft and piles. Concrete and steel of nearly 2,000 tons hold those sandstone cladding panels in place. Wind and sideways thrust try to push the dome outward, so compression rings and diagonal bracing tie everything back. Walk inside and you feel the weight above as a gentle press rather than a crack. That's the mark of engineering done to hide itself. If you've seen the cathedral's golden cupola from across Museum Island, you've seen a centuries-old problem solved with modern reinforcements and theatrical grandeur. If you're enjoying this journey, don't forget to like the video and subscribe to our channel for more city deep dives. From sacred stone to curated ruins, the museum tucks ancient gateways into a modern concrete and steel shell. The Pergamon Museum is an architectural paradox. It preserves ancient stone monuments inside a 20th-century concrete frame. Its 80-meter facade and lofty galleries create enormous loads, roughly 50,000 cubic meters of concrete underpinning a building that also carries heavy stone cladding. The exhibition halls need big clear spans to hold the Ishtar Gate and Market Gate of Miletus, so steel beam frameworks and reinforced trusses carry roof loads into a raft foundation. The team added seismic upgrades and flood barriers to protect relics from the spree. These aren't cosmetic, they change how lateral forces move through the structure. Walking its galleries, you sense both the weight of history and the invisible modern skeleton that keeps it stable. The stone you admire sits like armor over a concrete body, engineered for museum-scale loads and long-term conservation. Now look up. A concrete needle pierced the sky, an engineering problem of slenderness, wind, and public spectacle. The Fernsehturm is a concrete answer to an aerodynamic challenge. Build a 368-meter mast that won't wobble in wind and still holds elevators, a rotating restaurant, and heavy equipment. Slipform concrete created a shaft varying from about 27 meters at the base to 16 meters near the top, with wall thickness tapering from roughly 80 cm to 40 cm. The huge circular raft foundation, over 40 meters across and sunk about 10 meters, spreads the tower's 80,000 cubic meters of concrete and thousands of tons of steel into stable ground. The sphere, a 32-meter diameter stainless-clad volume, weighs several thousand tons and transfers its load down special bearing zones into the shaft. High-speed elevators climb at 6 meters per second, while the restaurant slowly rotates once every half hour, a small human-scale contraption inside a monstrous engineering stage. Seen from Alexanderplatz, it's both a broadcast machine and a civic landmark shaped by exacting structural math. From skyline monuments to street-level memory, a painted concrete ribbon still stands where the city was once split. The East Side Gallery is less about grand span and more about modular resilience. 1.3 kilometers of prefabricated reinforced concrete panels now act as canvas and structure. Each roughly 1.2-meter panel sits on an L-shaped base with a shallow foundation, and together they resist wind and occasional impacts by sharing loads across joints. The panels weigh a few tons each and anchor into piles or a shallow raft roughly a meter deep. That modest depth is enough because the panels work together like a picket fence resisting wind. Weathering, pollution, and human hands are the real stressors here. Restoration work in 2009, and ongoing maintenance focus on protecting murals while preserving structural joints. Walking the gallery is less about height and more about texture. You trace history on a concrete seam where engineering meets collective memory. Berlin's identity is a collage of stones, glass, copper domes, concrete shells, and painted walls, engineering choices that shaped history and everyday life. Which city should we explore next, and what secret do you want us to uncover there? Tell us in the comments.